we are told that f of x is equal to x squared plus 6x plus 5, and g of x is equal to 3 times 2 to the x. The table shows several values of each function and the growth factors, each output divided by the previous output. All right. Now, they're giving us a question. I haven't showed it to you yet. At what whole number of x does g of x first become greater than f of x? Pause this video, have a go at that. All right, so when x equals 1, and actually, before I even look at the table to answer the question, let's just think a little bit about each of these functions. This first function over here, this is a quadratic. How do I know it is a quadratic? Well, it's a polynomial where the highest degree term is a second degree term right over here, so that's what makes that a quadratic. And this one over here is an exponential. Exponential. It has the form some constant times something else to the x power, to something that might have something involving the x power over here. So now if we wanted to answer the question, we see at x equals 1, f of x is greater than g of x. At x equals 2, f of x is greater than g of x. X equals 3, f of x is greater than g of x. X equals 4, f of x is less than g of x. So even though it looks like g of x would have passed up f of x before 4, someplace in between x equals 3 and x equals 4, they're saying at what whole number value does g of x first become greater than f of x? So it looks like it happens at x equals 4. X equals 4 is my answer there. And now let's do the second part of this question. They are now asking, which statement best describes how the two functions grow as x increases? So the first choice says both functions grow by multiplying by the same factor each time. Well, that is true of an exponential. Every time you increase x by a whole number, you are essentially multiplying by 2 again. And you can see that right over here. If you take g of 2 divided by g of 1, that's what's happening here. This is g of 2 divided by g of 1, you get 2. And that keeps happening. Or another way of thinking, if you just look at g of x, for each successive x, g of x, we multiply by 2. We multiply by 2. We multiply by 2. We multiply by 2. And that makes sense, because it's 2 to the x power. So that's true of g of x, but it's definitely not true of f of x. If you look at the second term divided by the first term, it's 1.75, but it doesn't stay 1.75. Then it's roughly 1.52. So that growth factor changes. So this is not going to be true. It would have been true for g of x, but not for both of them. Both functions grow by adding the same amount each time. Well, that's definitely not the case. We can see that here. Here, from 12 to 21, we add 9. Then from 21 to 32, we add 11. So we already know that's not true there. And from 6 to 12, we add 6. And then from 12 to 24, we add 12. So we're definitely not adding the same amount every time. The exponential's function growth factor decreases, and the quadratic growth factor stays the same. Well, the growth factor is what you essentially multiply each successive term. Or essentially, if you take, say, the second term divided by the first term, or the third term divided by the second term. And we see the exponential, their growth factor is constant. It's a constant 2. So the exponential function's growth factor does not decrease. So hopefully D is our answer. Let's see. The quadratic function's growth factor decreases. We see that. The quadratic function's growth factor does indeed decrease. And the exponential function's growth factor stays the same. Yep, that's what we've already talked about. So we like choice D. Another insight to know, especially if we're trying to compare quadratic to exponential functions is, and it depends on where you start, etc., but in many cases, a quadratic, there are certain cases where an exponential can always be higher than a quadratic, but in many cases, a quadratic might start at a higher level, but the exponential will pass it up later on. And then beyond that point, the exponential will just keep growing faster and faster and faster. And you can actually even see that in the growth factor. It stays at a constant 2, while the quadratic, the growth factor decreases. If you think about it visually, a quadratic, maybe if I just think about where the quadratic is increasing, it might look something like this, while an exponential while an exponential might look something like this. That's my shaky hands attempt to do it. So at some point it's going to start, it's really going to be increasing much faster than a quadratic.